This facility is dedicated to the preparation of ultra-pure silicon. Workers meticulously monitor purity levels in this tightly controlled environment.
The silicon material enters the crystal growth preparation systems. Utilizing advanced automated dosing modules, we ensure the highest purity for premium CPU. The intense thermal glow signifies the crucial stage of ingot formation. Workers meticulously verify stability.
In this industrial documentary scene, we witness the precise temperature control required as the crystal seed slowly pulls the massive silicon ingot from the melt.
The thermal gradient is stabilizing. Confirmed, stress levels are dropping within parameters. Ready for the final pull speed reduction. Precision grinding is essential for the monocrystalline ingots. Robotic arms maneuver the materials as diamond tooling shapes the diameter behind these protective shields. The finishing corridor houses the automated polishing modules. Operators monitor wafer profiles in real time, utilizing advanced The spin rinse dryer ensures the wafers are pristine before the robotic arm carefully transfers them to the sealed FOUP carrier. Spin coating is a critical step. As the wafer accelerates, the viscous photoresist spreads evenly across the surface in a high-quality, uniform thin film. Inside the lithography bay, immense machines utilize deep ultraviolet light to pattern circuits invisible to the naked eye. Overlay accuracy on the peripheral dies seems inconsistent. Reworking the algorithm now. Sharpness verification conforms the issue.
The dry plasma etch chambers utilize advanced robotics to carve exposed patterns into the wafer surface, constantly monitored by workers ensuring stability. Utilizing advanced plasma etching cycles, we are witnessing the formation of nanoscale structures, precisely manipulated by robotic systems within the anti-contamination enclosure.
Check the flow on line 3. Is the pressure stable? Yes, stable. Adjusting the precursor flow now. These advanced process tools, linked by sealed transport systems, allow for the ultra-precise patterning required in transistor gate formation. The robotic arms manage the wafers as engineers verify the precise dose settings required for the implantation process.
The uniformity across the edge shows variation in this red zone.
Adjusting the beam energy now to compensate for the hot spots. This precision process activates the transistors, repairing the lattice structure damaged during the implantation process. This section here shows a critical dimension outlier on wafer 9. Rerunning the level 3 analysis now. The overlay looks unstable. Confirmed. The aspect ratio is inconsistent with the standard topography. We need to isolate this sector for further analysis immediately. This cluster here is driving the yield loss on the 300mm line. I agree. Rework the SPC limits on deposition layer 12 and monitor the impact. Interconnect layer fabrication begins here, as advanced vacuum tools deposit the first conductive materials for the CPU wiring.
The precision required for Intel's Core i9 Ultra chips demands these advanced barrier deposition chambers, ensuring flawless copper interconnects.
Utilizing chemical-mechanical planarization, the robotic system ensures precise trench filling and wafer uniformity across the modules. Engineers constantly verify the removal rates, guaranteeing that each interconnect layer is perfectly uniform before the next cycle begins.
The process relies on atomic precision, as wafers move through deposition and lithography, building complex multi-layer interconnects.
High-density interconnect verification is crucial for next-generation wafer technology. The optical tools precisely measure resistance data across the substrate. The completed wafers move steadily toward the electrical probe station for final testing. The automated electrical test system begins its critical analysis of the Intel Core i9 Ultra wafers.
Pasol values are stable. We should be clear for the next sequence.
Agreed. Logging the yield data now. Precision robotics allow us to screen thousands of dies simultaneously, analyzing thermal dynamics to ensure maximum yield and performance stability. The robotic handler initiates laser marking, assigning a unique digital serial number to the wafer, ensuring traceability throughout the singulation process. Here we see the protective tape lamination process. The wafers are secured by vacuum stages as technicians meticulously check the adhesion quality before dicing. Utilizing advanced vacuum tools and automated vision systems, these Intel Core i9 Ultra dies are precision transferred into classified trays. The machine vision system meticulously scans each die, identifying microscopic flaws invisible to the human eye. The robotic feeders precisely align the known good dies, moving them efficiently to the substrate preparation lines. This tightly organized process minimizes waste. Micron precision is essential as the robot meticulously positions the Intel Core i9 Ultra die onto the substrate. The automated system applies the specialized adhesive before the high-speed placement of the CPU die, a process monitored closely by the engineering team. The attached dies enter the controlled reflow modules, securing the die-to-substrate connections through precise thermal cycling.
This is the micro-bump interconnect joining process for the high-performance Core i9 Ultra, executed by precision tools in a sterile environment.
Interconnect integrity looks good on the Z-axis alignment. Confirmed. Proceeding with the thermal cycle. Ensuring the mechanical stability of the Intel Core i9 Ultra begins with automated reinforcement and the precise application of the thermal interface material. The imaging confirms internal connection failure in Unit 7. Yields will be impacted. Understood. I'm logging the non-conformance report now. High-speed oscilloscopes analyze the signal integrity, validating data transmission pathways under extreme load conditions. As the stress test begins, the cooling fans immediately ramp up to stabilize the silicon junction temperature under peak frequency load. The primary stack is approaching critical levels. Initiating emergency cooling sequence on bench 3. Here, the automated systems rigorously test and sort the CPUs into distinct performance bins, maintaining the highest standards of quality control. The system employs strict process logic. Rejected CPU packages are routed to secure analysis lanes, while approved units proceed to final marking.
Here, the robotic arm precisely applies serial codes and branding marks. The integrated machine vision system instantly verifies legibility.
Sealed CPU boxes move rapidly along the conveyors. Inspection cameras ensure accuracy, while folding modules and label applicators finalize the packaging process.
In the dispatch hall, precision is paramount. Final weight checks, seal verification, and labeling ensure every i9 Ultra is ready for shipment. Every Intel Core i9 shipment is secured in climate-controlled containers, protected by multi-factor digital locking mechanisms and continuous scanning checkpoints. X-ray indicates a high probability of solder bridging on the southeast quadrant. Let's run a decapsulation on that specific die for visual confirmation.
Yield data on the i9 Ultra is dropping fast. Look at this defect trend on the wafer map. We're seeing contamination spikes correlating to the robotic transfer.
Readings on manifold look stable. Copy that. Proceeding with the alignment sequence.
Precision diagnostics across the Intel Core i9 Ultra network confirm system readiness. With the carriers moving and monitors flashing green, the production sequence is clear for launch.
Here, in the heart of the facility, lithography, etch, deposition, and implant processes operate in seamless parallel.
In this back-end assembly workflow, we see dies attaching, lids mounting, and products moving rapidly through test racks and packaging conveyors. Thermal load on Core 7 just spiked. We need to check the telemetry now. Adjusting the voltage regulator. Levels are stabilizing. Stress test complete. Certification confirmed.
The new classification software ensures every Core i9 Ultra meets the premium performance criteria before automated routing. Utilizing advanced robotics, the inspection chain ensures every package meets stringent quality standards before moving to the final palletization phase.
The yield dip on the i9 Ultra line started precisely at 0400 hours.
Do we have a containment plan for the silicon?
The wafers move seamlessly between the critical steps: lithography, etch, deposition, and metrology, all handled with absolute precision. From raw silicon to the intricate architecture of the Core i9, this facility manufactures the future of computing. From these pristine production lines, the Intel Core i9 Ultra is carefully prepared for dispatch, destined for systems worldwide. Automated systems finalize the Intel Core i9 Ultra. Advanced packaging, performance binning, and secure dispatch, all synchronized in